Hello, everybody, and welcome to another episode of Show Me SaaS. Glad you could join us again here. I've got the usual cast with me here today. Bill, Bill, you're down there in the bottom left corner for me. Raise your hand, Michael, say hello, and Toby. You've seen our faces before if you've watched the show, so we'll move past the intros and get to today's topic, which is tenant isolation. And if you've looked across any of the sort of SaaS content we've talked about, tenant isolation comes up in so many different discussions and so many different contexts. And in reality, we see lots of people sort of have sort of different notions of what they're thinking about when they're thinking about tenant isolation. So I thought it'd be really cool to kind of do an episode that just maybe try to come at this from a high enough level that you could say, how could we sort of break the discussion of tenant isolation down and categorize this and give a landscape to what it means to isolate resources in a multi-tenant environment, and at least the way we talk about it in the different customers we talk to. There's no absolutes around this, but we do have some sort of terminology and patterns we think that are common here, and with the idea that hopefully walking those patterns is going to be useful to you in terms of figuring out, well, how and where do I apply isolation? Because the hard part of isolation is it often means it's many things inside of your application. It's not one. And so ideally with this session, we'll kind of talk about, as we usually do, some of the conceptual bits of isolation, and then we'll slowly work our way into specific examples, and we'll look at stacks and different technologies and different sort of considerations that are sort of that show up as you wander into the detail of isolating using specific sort of tools and mechanisms. And we'll probably just leave you with, sadly, with the takeaway that you're still going to have to go away and sort of figure out what it means for you. But I don't know if you guys want to add any more flavor to the sort of isolation story, anything you see or sort of challenges you see around this before we start to dig in.
I just think it'll be important to talk about what isolation isn't, right? And I think that sometimes people use other terms and they call it isolation, and it's not really isolation. Like partitioning isn't isolation, authorization is not isolation, right? And we'll get in that today, but I think that's important to
I think in fact that's a good segue maybe, Michael, to where we really want to go here. When we say isolation, at least, what do we mean, right? Because what are some of the areas sort of people might confuse it, right? Because I will see deployment model, for example. It's a term I use, deployment model, which is I'm like full stack isolation or something. They'll say, plus full stack silo. And they'll say, that's my isolation model. And I'm like, or I'm going to give a separate database to each tenant. And they'll say, that's my isolation model. And I'll say, no, it supports your isolation model. It's influencing your isolation model. But there's nothing that prevents somebody from accessing that resource just because you put it in its own sort of mechanism, right?
Right. I like to think of isolation as like the enforcement of the rule that you don't want party A, interacting with party B's, whatever, database, network, file system, what have you. So it's the enforcement of the rule.
But to challenge that, then how is that different than authorization? Just being devil's advocate here. I don't want you to beat me up or anything.
Is it the outfit that makes you think that, Toby?
Michael, if you just punch upwards, you'll get it.
Right. I think it's back to what Todd was saying. Like if you look at database partitioning, just because you have put tenant A's data, tenant one's data in one place and tenant two's data in another, and you've separated them, maybe physically on disk or whatever, it doesn't mean that that implies that tenant one can't access tenant two's space. And isolation is about not being able to access that space. And I think for authorization, I often think of it's a good point. Sometimes I think of authorization more like a API call or like a nuance within a single logical flow of business logic like I want to, register, I want to check out, or I want to pay for this item, or I want to search this catalog. And maybe you're authorized to search, but there's different filters or levels or nuance to what you can bring back in that search. And maybe that's authorization versus isolation, which is saying, when I'm searching, I can't touch this resource. Or
it doesn't even like appear,
or it doesn't exist.
Yeah, exactly.
Right?
Yeah. Let me jump in on that one, Todd, because I think it's an interesting discussion to try to contextualize. And sometimes when I think about isolation, I like to step back from the technical aspect of it and think of like a real world example, like a hospital, where isolation actually is a real world term. And we think about isolation as an extreme contract around what is allowed to happen and what isn't. When you have an isolation ward, there's extreme reasons why you wouldn't want anyone who's not allowed into that isolation ward in. And so it's similar with tenants. It's a contract that you're creating with your tenancy and saying, like if you rented an apartment, for example, I have absolute control over this apartment to a point, to the contract obligations that you've given to me. Like, perhaps the tenant owner can come in for certain reasons, but other than that, I have exclusive use over this space. And I have a contract saying no one else should ever get into this space. And that contract is different than roles or authorization. We may have different people who can come in for different reasons, like a plumber, but they may not be part of that tenancy. That tenancy is my family, perhaps in the case of an apartment, or the case of a hospital. That isolation may be only people who have the right training to be able to handle the disease that's being handled in that isolated space.
And authorization can live inside, like it's smaller than isolation. Right. And to use your analogy, maybe you're allowed to go into the lab in the isolated ward or not. Right. Or in the family, the parents are allowed to turn on the stove, but not the kids, but everybody belongs to the apartment, kind of a thing.
Right. Yeah.
Exactly that. Yeah.
I think it's scopes. I think it's just scopes. And the word authorization always gets us in trouble because there's these sort of application notions of authorization that I at least tend to gravitate to. But to me, it's like, there's a scope within which you're inside a tenant, and then you're being allowed to do something, or you're not inside that tenant. And that classically sort of maps to authorization. It doesn't have to. And then there's a scope outside of that, which is at a system sort of level, which is to say, I'm in the scope of this tenant, and I can't cross some boundary to another tenant. That to me is isolation. And to me, that is not a feature of an application. We don't turn on bits and pieces of isolation. These are hard and fast boundaries to say these are tenant one resources, these are tenant two resources, and they are intentionally isolated in a way that you can't cross the boundary, no matter what the application running in that tenant is doing. Whereas when I feel like authorization is more classically like a set of operations within the scope of an individual tenant that says, you can perform this operation or you can't. I don't think those are hard and fast rules. I just think that's how I sort of separate it in my mind. You certainly could say isolation is another layer of authorization that's at a broader scope. But I think it sort of confuses things because I think people are often bringing role-based access and other things into this discussion when they're thinking about, is that my isolation? And it's not. So I don't know, Toby, did that satisfy you?
Yeah, no, I think so. I mean, I guess, from it boils down to kind of the physical aspects of it versus the experience of it. Right. So, in isolation, you've got some separation, perhaps physical, perhaps not, but it's kind of the way you've architected it versus the way your users would experience it. In both cases, whether it's isolation happening at the application level or at some other level, the tenant should feel like they're, like if a family's in their apartment, there should be no other family in that apartment, right? Like they shouldn't be able to see through the wall to the next family.
Right.
But
that would be
but so from their experience, it's like they're alone, right? So that from an experience perspective, it's the same. But whether or not, we've got how it's implemented is a more of a function of the isolation bit.
Right. And two things I most classically want to be sure we're clear about, I think, because I just see them all the time and we're being sort of repeating ourselves, which is the deployment of a resource in a dedicated fashion to a given tenant is not isolation. That is just, you have provisioned and made it separate, but until you do something to prevent access to that resource from another tenant, you have not achieved isolation. That is essential to me. And that's like Michael talking about data partitioning, and I'll see people talking about data partitioning and isolation as the same thing, and I get all sort of squishy about that, and it doesn't feel right to me. And the other one, and I may be pulling this ahead from below, but I think it's maybe better to talk about here. I also run into security people. Like if you go to talk to service teams at AWS, and you go talk to people who are just all day long building multi-tenant infrastructure services, and they're thinking about multi-tenancy and isolation, they're thinking of it entirely through this sort of lens of like a security and protection of the underlying infrastructure, which is super important. But when they use that same word isolation to describe that notion of isolation, and to me that is this infrastructure notion of isolation. But then on top of that, which is the bit we're mostly talking about, we're using the same word isolation to talk about more of an application notion of isolation, which is that we're somewhere in the code we're writing that's running on that multi-tenant infrastructure, we're still having to ensure that one thing can't cross another. So anyway, that's just maybe a little bit of maybe an internal red flag that I run into, which is when we talk to isolation to different organizations, when you run into security people, they're like, that's not tenant isolation, because they're thinking about this very much lower level notion of isolation.
Yeah, we'll touch on that when we get to the container stuff, right?
Okay, but let's go back to the thing Michael was talking about, just to tie this off though, right? Which is, so if I implement isolation, but then somewhere in my application, I also have within the scope of a tenant, this authorization context where can you do this? Can this user and this role perform this operation? And that's potentially turning things on and off in my UI because I'm not an admin or I'm not in a specific role that lets me do that operation. Do you view the implementation of that application notion of role-based access is somehow bleeding into the system notion of isolation, or do you see those as entirely two separate buckets? Like how I go access that application notion is very different than my tenant isolation. Does that make sense? Or is that?
Well, I don't know that I would. So the technology that you might leverage to enforce it might be the same, might be security groups, might be IAM roles or policies more precisely, might be RBAC based on your identity provider, something like that, or tag-based attribute, controls. So the technology building blocks that you use to enforce those rules might be different. But in my head, when I think about isolation, to me, isolation is sort of at the tenant level, not at the individual identity level. And then authorization is at that identity or user level. And that user in a multi-tenant system is always acting within the context of the tenant that owns it. But from an isolation standpoint, the system needs to isolate tenants from one another. And then it's up to the application to make sure that if it's a multi-user application, which often they are, that the application protects itself from user A doing something that would impact user B if that is a requirement of that piece of software. But that's sort of on the software side. That's how I think of it.
Yeah, and the reason I bring it up is because like you'll spend a lot of time talking to somebody about how to build their tenant isolation. And we talked a little bit about this in a prior episode, so I don't want to go too deep here, but we talked about the fact that I established my identity with the identity provider, and I could put certain claims in there that are used to enforce my tenant isolation. And what I will see people saying is, hey, I have this whole other application notion of isolation, and they want to shove all those things into one implementation, right? Like my identity that if enforces my tenant isolation will be the same mechanism that will be used to do these application notions of, and if it's one or two things, those two could probably be put in the same place. But what I get nervous about is when somebody's got like, there's there's 80 different rules with like 50 different attributes that are managing this authorization at the application level, and they're churning all the time as new features and everything are coming in. Versus if you look at tenant isolation, like it's pretty, once it's set, it's pretty set. It's morphing a little bit, but it changes very infrequently. And so I get nervous about people putting those two things in the same box and trying to solve them with the same tool sometimes.
Yeah, I just to expound on that a little bit, Todd. As I think about some of the identity providers out there, like Auth0 or Cognito, it's sort of a decision you make in the beginning about your tenant isolation model, and you say, I'm going to do a user pool per tenant, or I'm going to do a application per tenant in the case of perhaps an Auth0. That tenant isolation is going to be pretty hard to change after the fact. You're creating pools of users, but roles are pretty flexible, right? I can say, oh, Michael, you're an admin today, but tomorrow I'm going to take away those admin rights and you're going to be something else. And so there's an absolute nature to isolation for tenancy that I see that it may not be completely immutable. Like you said, there might be some cases, maybe company A buys company B and that tenant isolation model may change a little bit. But on a day-to-day basis, I want to think of tenancy as pretty much an absolute boundary around a specific set of features and functionalities. And I don't ever want to see those crossing over. Whereas roles and responsibilities tomorrow might be different, right?
Yeah, I think that's a good way to think about it. A little more churn happening on the role dimension, but tenancy kind of thought about upfront as a hard line.
Mm-hmm. Cool. So that's like the sort of philosophical sort of mindset, if you will, of behind isolation. Let's shift gears a little bit and talk about like how can we categorize and try to give some terminology to different flavors of isolation. And I feel like this has been a fluid space as long as I've been working in the SaaS domain. So I don't know that we've like nailed it. This will be forever the way that people talk about isolation, but from now at least it feels like a reasonable sort of categorization of isolation. So for me, I break isolation down into categories based on the sort of the scope of the thing being isolated. And I said wrap in my diagram. Oh well, we'll live with a bad PowerPoint moment. So full stack isolation is really meant to say every single tenant is going to have an like this really hard and fast boundary about all their resources. Like everything for that tenant is put into one box.
Compute, network,
everything.
Yeah, file storage, everything.
Right, and we'll talk about what those are. But obviously, to isolate in that environment is a very different thing versus environments where we start to sort of mingle, like which things are dedicated and which things are not dedicated to a tenant. So generally, like sometimes I think, in fact, people gravitate to the full stack isolation model because it seems easier. Like, because you have to say from a dev perspective, I think, I don't know if you guys agree or not, like full stack seems like the simplest isolation story to tell.
Oh yeah,
but application level, but goodness, from an infrastructure level, it is super complicated to manage.
Yeah. So that's the downside of it, right? Like that. In fact, I had this exact conversation with a customer the other day, which is they were like, we're going full stack ISO, we're going full stack because we have all these compliance needs. And then we started talking about all the complexity of like managing how distributed these things, the scale of this, the economies of scale that you would get out of this environment. And then they were like, maybe not, right? Like, right. So I think it's just tempting if you're only talking about isolation and compliance. Like somebody's like, I can tell that story to my customer. It's like, yeah, but there's more that comes with that. It's not free. But anyway, it is a good isolation story and absolutely valid for some customer environments. Now the next one to me, and this one's name is maybe needs to morph some, but the idea is the resource level, which is within a stack of all the things that I have for a tenant. Some individual resources can be dedicated to a tenant. So a database could be dedicated to a tenant. A queue could be dedicated to a tenant. You're saying that at that resource level, everything in that resource belongs exclusively to that tenant, but other things in the tenant may not be. They could be shared, they could be pooled or whatever. And this one is, I think, obviously really still makes isolation somewhat simpler, although the nuances are interesting here in that if that resource has a really natural way to protect access to it at the resource level, it's isolation still easier to build here, right? So a DynamoDB table, which is an example we always will use, I can build an IAM policy to say you can't protect that. For RDS and other storage technologies, for example, though, some things let you control at that level and some things do not.
Yeah.
I don't think resource level automatically means it's easy, I guess, is where I'm going with that. I don't know if you guys agree with that or not, but I feel like resource level can still be a bit of a mixed bag.
It can, for sure. And I mean, just to make sure everyone's kind of attaching to that concept too, I want to go back to my my apartment analogy again. And some things in an apartment are fairly easy to lock down. Like everyone gets a mailbox, for example, and everyone gets a key to their own mailbox. And you may have joint use of the mail room, but you have a key to your specific mailbox. But there's other things that are much harder to isolate, like your parking spot, for example. It's easy to say you have an assigned parking spot, but anyone who's ever had an assigned parking spot knows eventually someone else is going to park in it. So we don't want that scenario with our resources. And that's exactly what you're getting to, Todd, is some things like an S3 bucket are very easy to put the keys in front of it and say, Toby, here's your S3 bucket. Michael, here's your S3 bucket. Other things are a lot harder. And if you're using external services, for example, like MongoDB Atlas, or if you're using some of our internal services, even like RDS, it's not as easy to simply say, hey, this one's yours, and we can create layers of security around that say no one else can get into it. But it's an important concept to connect to and realize that getting that type of resource level isolation is really a best practice. And wherever we can nail that down and say, listen, this in our security outside of my application, I've got a restriction that says you can only access this specific resource. We always want to go down that road if possible, in my opinion.
By the way, this is just to go ahead, Michael.
I was just going to say that the challenge is how do you bridge the gap beyond convention, right?
Yes.
So to use the analogy, sure, you've got a parking spot, your unit number is painted in yellow paint in your parking stall, and no one else is supposed to park there, but it's only by convention that somebody looks at that. There's no enforcement of that rule. And sometimes we find that with some of the types of infrastructure resources that are available to us in cloud computing. And sometimes all you can do is paint the number in yellow paint and hope that everybody follows the rules. So part of the challenge is figuring out how do you enforce it.
I've seen to extend that metaphor even further. Hopefully it doesn't turn into a dead horse.
Right.
But I've seen applications. I actually used to work for a company that had what they called isolation, but it was strictly by convention. And there was some long GUID on the end of a URL that was that tenant's view into the system. But if you happen to know the GUID of another tenant, you could throw it in there, and there was nothing to prevent you from seeing. Like you could park in that spot all you wanted.
Right.
Well, I feel compelled to add to the analogy of the metaphor here.
We're just abusing.
That's where we're going. So imagine instead of having painted stalls, that we had an enclosed structure that was yours, right, and a door that you had a key to either open, or a remote that was your unique
like
access key, right?
Crazy. What a great name for that.
Whatever that is, like in that model, that's still sort of like some resources will give you the garage door opener as a way to get to them, and others only let you paint the number on the slot, right? And the problem here is, as the builder here of this system, and this is the hard news we often have to deliver in the isolation story, is you still have to make both of those work. You can't just say, well, it's a painted slot, I can't do anything else. You still have to figure out something to do there. And it may not be a tool that's in the toolbox that you have in front of you right now. You may have to write a tool, you may have to go find a tool, That's the harsh reality of isolation that, I don't know about, like, as long as I've been in this space, I've talked to Michael and Toby and others about like looking for that magic bullet proxy sidecar, something that would like just make all of this work for every service. And we still haven't found it.
OPA comes up a lot in conversation, open policy.
Agent.
But agent.
Now, this even gets more interesting if you look at the last flavor of this, which is what I call item level isolation. And the key thing here is you'll notice that the tenants items are inside of the resource. So here it's some shared resource, and we're representing. So this, obviously the easy ones here to talk about are like databases where we store we use a key and we store all the data in there. But this could be queues. This could be indexes inside of Elasticsearch. It could be any number of different things. So the idea is that we are truly commingling the items that belong to an individual tenant to multiple tenants inside the same resource. And of course, this is the view of multi-tenancy that most people in a classic world say you're not multi-tenant somehow till you get there. But when we've talked about why that's not true, in this case, all of these are multi-tenant to me. But here now at the item level, you've really raised the bar in terms of like, what do you do here? Like, because we've talked about painting the slot and a key to get in the door. Now, like what do you paint on the ground? What is the analogy that somehow says I've got some awesome security mechanism that can say you can only see tenant one's resources in tenant one's items inside this resource?
Right.
I mean, in some cases, it might be less of an issue, right? If it's just a transport, for instance, to use the queue as an example. Right. So you put something in there and everybody's using the same queue and you put some piece of data destined for a service that is for tenant one. If that service then has precautions or safeguards in place to make sure that when it plucks that item off the queue, that it's checking or it's doing whatever that's tenant appropriate, then maybe the transport of that being commingled with other tenants isn't that big of a deal, because if somebody were able to kind of hijack it, we've got something downstream that's gonna make sure that it's still the right thing to do. I don't know if there's other examples like that, but I can imagine like simple stuff like that might not be, again, there's a spectrum of appetite for what your isolation could be, right? If you're, and if you're on one end of the extreme, maybe that isn't a good thing, but I could imagine cases where it's okay.
Yeah, it's a good conversation, which we have with customers is where do we need to enforce tenant isolation, right? So you've got this big solution, you've got software running all over the place, but you've got this infrastructure that glues together your workflows, whether it's temporary file storage for temporary file uploads before they're processed. Well, it's the processing, right, that really is the tenant isolated activity, or like you say, or there's or like an IoT, MQTT, broker that's like getting all of the events that are coming in of telemetry from these devices, but it's the act on that telemetry data that needs to be isolated more so, maybe depending on the workload than the actual plumbing itself.
Yeah. So I want to ask a question around this, because I feel I've got this back from customers. I know, Michael, you've been in this space. I think we all have to some degree, but let's say that's a relational database and that item level isolation, and I've got rows that belong to different tenants inside there, and I've got a foreign key that is my tenant identifier. And I look at the code that's going to access this, and somewhere in the code that accesses this, there's a where clause in my SQL statement that says where tenant ID equals tenant one, right, or whatever.
Right.
And when I deal with customers and we talk about tenant isolation, they'll point to that line and say, there's my tenant isolation, because like that line will only get data for that tenant.
Yep.
And I'm curious, like, is that isolation? I certainly have an opinion about that, but I'm curious what you guys think.
I would say yes. It does isolate things as long as you trust the query planner for the database engine that you're using. to not leak data. So often what happens in complicated SQL is you end up doing, correlated subqueries and other aggregations that people often don't isolate those aggregations as well. They only isolate on the outer part of the query, and you can leak tenant data, other tenant data inside your query and get different results. So that's like deep relational database geekery that we could talk about on a different episode. But I think where I think about the conversation with sort of the where clause or whatnot is sort of like the security conversation. We always tell people, do all of your security or your validation at every level. So your website, your JavaScript should be validating the user input into the form. Your service that is accepting the post of the form data should be validating the data before it acts on it, right? The data layer before it stores it should be validating the data before it stores it, right? And sort of similarly at every layer that we would like to enforce isolation. So if you can have an opportunity with a relational database where you can enforce these isolation rules or policies at a lower level than the SQL statement, then do it. Just like if you go into a network and you can write an IP firewall rule, that's at a lower level than anything your application is doing. And so you're sort of protecting yourself. You've got that extra seatbelt, that extra safety net from any developer making an unintended error or forgetting something in a where clause or kind of going off on their own and lighting up a new microservice and using a new technology stack and doing modern development and then not following the patterns
Right.
that have been there before.
So for me, I feel like that scenario I used before where we've got this GUID on the end of a URL, right? The code. So again, to Todd's point, where we point at that line and say, well, there's our isolation, because obviously, that GUID is going to be some tenant ID, and it's going to make sure that whoever interacts with that is going to be tenant ID. So in this particular code, that's exactly what happened. The GUID came off the end, and it entered the dynamic where clause, and we were all dealing with only data with that tenant. But what wasn't part of the equation was the identity of the caller, right? So the database was just a database and do you have select permissions on this table? Sure. And you enter any GUID in there and it could pull back that data. But what the missing link here that provided actually that tenant level isolation was the logged in user who's actually making that call. We needed to have an additional layer there that said, that guy does correspond to that ID and can make that call. Because without that, everything was just, it was just security by obfuscation.
Yeah. Let me, since I'm the self-appointed analogy guy today, let me go to an analogy for this.
Don't give us an apartment or a parking spot, though.
I'm going to do even one better this time. I've got a food cart, right? So if you're walking around with a food cart and inside of that food cart, you have food for all of the different people. If you had, for example, something that let people sort of self-service and you could scan your badge or whatever, and you could pull out your food, you're sort of trusting people to only reach in and pull out the right food, right? And this is sort of our where clause analogy. If you trust your developers to be the sole point of security, and then, well, I mean, that's good as long as nobody makes a mistake and grabs the wrong food or anything else. Going to the next level is, talking about layers of security around this food cart. Maybe I should have someone accompanying the food cart who's actually double checking and making sure that everyone's taking out the right food. And if you don't have that, if you're just putting the trust into, single people to provide your levels of tenant isolation, to me, for the most part, that seems insufficient, at least depending what the data is. If we say we really don't care if we leak this data, this is just metadata or something else, that's one conversation. If this is anything that we care about at all, if there was any reason we would care that one tenant were to ever see another tenant's information, then you have to have layers of security built around that. And those layers of security should have different levels of responsibility for who can touch that code. Todd, if you were the lead developer on my project, I would want you being the guy who coded the person who walks around, if you want to use that analogy, gives him his instructions of how he should do his job, versus maybe me, the day-to-day developer who knows how to, tell people how to use their card and scan and pull out the right food. But yeah, again, there should be different responsibilities, separation of responsibilities between those roles for me.
Yeah, now you went and made me hungry is the problem here, Bill. So I
don't choose the egg salad sandwich. It's been.
I think we beat this one to death a little bit. I will say I'm in that category of I ideally, like, where clause isn't enough to me. If you like, I want that other layer. You don't always have that other layer, but like. Right. We've done stuff, Michael's done stuff with row level security here, where you can still, with row level security in Postgres, like apply this extra layer of security, and no matter what's in your where clause, you're not going to get the data back, right? So ideally, I don't want to count on a developer to get this right, even if they're well intended. But it points out the challenge of isolation. The weird part is, we want people to be in these shared item level isolation kind of models, because sometimes the best economies of scale for multi-tenant environments come in these areas where we share a resource across tenants. Mm-hmm. And so there's always this sort of angst here of like, okay, I'm going to go back to resource level isolation. Well, maybe you should only do that for some tenants. And this is where we get into tiering and all the other things we get at. So a noisy neighbor might get in that discussion.
And I also think it can influence your technology choices. Sure. Right. So very explicitly, Postgres offers a policy engine inside of it called row level security. So does SQL Server. MySQL doesn't. Right. MariaDB, MySQL, there is no feature of that. So if I'm working with a customer and we're talking about this layered security model and getting the security enforcement out of the day-to-day developer's hands to minimize our surface area for exploit and our risk, that may drive somebody to say, well, can we use Postgres for your solution instead of MySQL? Both great solutions, great pieces of technology, but this one has a feature that will make tenant isolation for your multi-tenant system better than this other one, right? So all else being equal, maybe you should choose this or the other. And there are examples like that of choices between different complementary, technology stacks that I think go into this too.
Yeah, and I just while we're on, like, obviously we're not going to dig into like all the different flavors of what it means to be, full stack silo sort of isolation, which is like account per tenant, VPC per tenant, and what are all the constructs there. And the resource level ones kind of depend on, am I a database or what kind of construct am I protecting? But at the item level, we have, I do think it's interesting only in that we could sort of give you a more concrete example of a way to do this that does introduce that layer we're all talking about, right? And you'll see this across tons of our examples, our reference architectures. Bill built and I think Michael worked on this too, this dynamic policy generator that we have that does all this. And the basic idea is somewhere we create an IAM policy, and that IAM policy ends up being the enforcer of your isolation. And we essentially get the credentials back from that policy, and those credentials are used to scope your access to the resource. So that in an ideal world, the developer's essentially saying, I'm about to go access this resource. Give me the creds to access that resource. And whatever you're doing behind the scenes in the voodoo of tenant isolation, giving me back a set of creds that will enforce that. And then I'm just going to go access that resource and count on those creds to do whatever they need to do to prevent me from crossing a tenant boundary. And one example of that in item level isolation here is a DynamoDB table where the condition part of our IAM policy includes some qualifier that scopes the access down to a given tenant. But we can do this across any number of different resources. In fact, we'll probably do a separate show on the dynamic policy generation here soon, so you can just dig into the nuances of everything that's going on under the hood of that. But to me, I wanted to bring something concrete to this item level sort of discussion. Really, this could apply to resource level as well, because this condition could be a condition in IAM policy that is scoping your access to an entire table or scoping your access to some database as well.
Right, and I think what we've been talking about maybe without saying as much. The challenge is that not every AWS service has a condition clause available in the IAM controls over that resource. And that's the challenge. Many of them do, and more of them are adding them over
it's
time.
mostly the cloud native stuff, right? Like the stuff that was born in the cloud seems to be that direction. But if you if you look at like the databases that existed that just now have cloud variants or whatever.
Yeah, the more something has an external mapping, the more difficult it is for IAM to offer these sort of more nuanced ways to get to it. So that is like, people see this and they're like, awesome, I'm going to go do this. This is exactly what will solve all my tenant isolation problems. And then they go, well, I'm not using DynamoDB, I'm using some other service. And you're like, well, for that service, there isn't an IAM sort of mapping that might be exactly what you want, right? So definitely sort of something to remember. But okay, so if we talk about that dimension of the problem, like full stack, ISO, resource, and item, there's also another layer to talk about this discussion of isolation, which is more related to when the isolation is applied. And I started with this one that is called, what I called deployment-driven resource isolation, which is to say that the moment a resource is deployed, we're actually attaching the isolation sort of rules to that. And in this model, it's almost a DevOps-y kind of moment, right? Which is to say, my deployment, my DevOps, and the provisioning and the configuration of this infrastructure is going to be inclusive of a part of my isolation story, at least. And this can be different across different AWS services. So I've got a few here. I guess for me, is there any other nuance to this other than saying, hey, basically I can take an IAM policy, and at the time of deployment, like an EC2 instance, I can tap an instance profile, and I can use that instance profile to scope down the access of a given tenant. Or at Lambda, I can attach an execution role. Are there any other caveats to this deployment-driven approach that we should be thinking about?
Well, if you have tenants sharing that resource, then they're all going to be sharing that same set of IAM policies, which is going to defeat your purpose. So this only works when the resource that you're applying that profile to, whether it's a task execution role in containers or instance in EC2 or execution for Lambda, it can only apply to one tenant at a time. Otherwise, you get into what Bill was working on, which is the dynamic policy, which is, I've got lots of tenants sharing this, so I'm going to go get the policy at runtime. But at deployment time, I think this, correct me if I'm wrong, I think this only works
in silo.
Is a silo.
Yeah, that's absolutely true. That's the downside of this, right? Which is, in fact, if you look at the serverless SaaS reference architecture that we have out there, it's sort of interesting is because it has the mix of these two things. It has, for premium tier tenants, they get siloed Lambda functions and they deploy them with an execution role. But then for basic tier tenants, they're sharing the Lambda functions, and then they have to use the runtime sort of determined model. So yeah, this seems really tempting and like, oh, this is it. This solves lots of my problems. But again, it's constrained to the silo model only.
Yeah. Not that we should discount that. A silo model has plenty of applicability to many applications.
It does.
So
it could be for a siloed resource, right? This doesn't mean your whole stack has to be siloed. It could be that this particular compute is siloed for this particular microservice, and therefore I'm using an execution role, right? So it is more granular. That often gets lost in the silo discussion. Mm-hmm. Now, the other variation of this, unless anybody, we have anything to add around this one that I might have not included here?
Just to say that containers can also have the same.
Yeah, I had a container version of this. And I couldn't fit it all on the slide without it being too busy. But yes,
just
absolutely.
So everybody knows that, yeah, you attach an IAM policy to a container, and that's the scope that container operates under.
Awesome. So then the other flavor of this is what we've kind of hinted at already, is this notion of runtime enforced isolation. And this is basically saying, I'm going to wait and I can't know isolation until I'm processing the request of some tenant. And Bill, obviously, I know this is kind of a higher level sort of view into the world of dynamic policy generation, but can you like talk about the sort of fundamentals of how this works?
Right. And this is where it again naturally ties back into our identity provider and the JOT tokens coming in, because that's usually the mechanism that we're thinking about when we're talking about this type of policy. Is I'm expecting my tenant identity or my SaaS context, which is one of the terms that we use for it, to be coming in from an identity provider. And by the time I reach this point, I have a strong idea of exactly how I should be able to scope the resources for the current execution context that I'm in. So I can reach back, I can confirm that identity. Having that verifiable is an important ingredient of this solution. So, and making sure that the JOT token hasn't been interfered with using the certificates issued by Cognito or Auth0 or whoever else. But then taking those and applying those to IAM policies, or potentially a different policy engine if we were to build your own, I suppose, but certainly to IAM policies, and saying, listen, I've got that tenant identity. I can trust that tenant identity, and I can scope access to only the specific resources that are allowed for this tenant identity. And that creates a strong tie-in between your tenant isolation and any of the resources that you're executing, even though you're in a shared or a pooled context here, where it may be executing for a different tenant the next time this Lambda or this EC2, this EC2 container, this EKS container, or this EC2 perhaps even, in some extreme cases. But usually we want to make sure that all of those pieces verify that tenant identity and apply that scope accordingly.
Does this only work if our tenants look like Bob Ross?
I do think that the big takeaway here is that when you deploy the compute here, you have to deploy it with a wider scope, right? It has to be deployed with a scope that can take a request from any tenant, and then really you're saying, I'm going to resolve context, inject the right credentials, and apply them, and then use those credentials as I leave the compute to go access something else, and count on that. Restricting it. So this could be any number of things being accessed from the compute in the context of a tenant, and but your compute itself is running in a wider overall IAM context.
Which for some folks is not great, right? Like I know that I've had customers where I've pitched the dynamic policy and they're a little about having that broader, because it's the Venn diagram. It's drawing a circle around all of those intersections. That is the totality of the permissions needed.
Right.
It's cool.
Yeah.
But Bob Ross can do whatever he wants. He has permission to do anything and everything he wants. So
just want to make sure people, just to be really concrete, depending on who our audience is here and whether they just to sort of say it out loud, what we're talking about is anytime you instantiate an AWS SDK client. So whenever you use a library from AWS to communicate with Dynamo or S3 or SQS or TimeStream or any of our services, that's what we're talking about, is that SDK client, when you instantiate it inside your code, whatever language you're using, that instance of that client operates within the context of an IAM role. And that role has one or more policies attached to it. So that's when we're talking about going and talking to these other resources, it's those white arrows on the bottom of this slide here, going to the blue boxes. That's what we're talking about, just to be real clear. It's not code inside. It's not your business logic going to your different functions. It's going out and talking to an AWS service. That's what we're talking about protecting.
Cool. So I'm going to speed up just a little bit, just because I want to see if how much of this we can fit in. But I want to talk about, this is an example of EKS and a way to apply this in EKS. But I want to back up from EKS first before we talk about EKS, and just generally say, like, what is the isolation story for containers in general, right? Like when we look at ECS or EKS, or we look at Fargate, like, like we talked about deployment, we talked about runtime. Does the container universe have some unique set of needs here that would mean the way I apply deployment or runtime would look different potentially? And certainly I've got an example here of what it would look like in EKS, but in general, are you still just attaching IAM policies if you're siloed and then using runtime if you're not, or is there more to it than that in containers?
There's just that other layer, because you might be running more than one container on a piece of compute, and the multiple container instances that are running may be apportioned or applied to different tenants. And so I think that's the key, for sure. That's the extra question that you have to ask yourself.
But like in EKS here, this is just like it talks about, this is called URSA, right? Where you can attach to a service account. And this is just service account, just happens to be an EKS sort of construct here. I can attach a policy to it, and that policy will essentially control the scope of access for that particular microservice running in that namespace in this case. And this is
the key point here is that if this were just, say, some workload running on an EC2 instance, that workload could, through dynamic policy generation, go grab its own identity and its own policy and generate a client with credentials that reached out and did whatever it did. Or you could apply an identity to the instance, and it would reach out to touch whatever resources with those credentials. EKS goes one level further and says, and ECS does the same thing. EKS goes one level further and says, it's not just the host that these containers are running on, but the service account that are running these containers can also have an identity that trumps that of the host. So that just another it's almost like layers of that onion, right? Like several different ways to get at the same type of information.
Yeah. Now I'm curious though, if you look at like other technologies, I'm going to skip ahead a little bit to this. This notion of escapability comes up as another layer of concern in the isolation discussion, which is to say, even if I've put in like service level accounts and I've attached IAM policies and my code's complying with all of that, in this container space, whether it's EKS or ECS or whatever I'm running on, there's always this concern about, can I escape the container and get access to something I'm not supposed to be able to get access to? And I don't put that on the same level as classic sort of tenant isolation, but it's still a concern that anybody running in a container-based environment has to think about in terms of what they could do for escapability. And there's a couple of ways to approach this, right? Like what are my options if I'm worried about escapability in a multi-tenant environment?
Well, the easy answer is Fargate.
Right.
Because an implementation detail of Fargate happens to be that AWS promises it will only put one container on one piece of compute. And so you're isolated because of how the service works. So the easy answer is, if you're really worried about escapability, use Fargate. If you don't want to use Fargate, either because you can't, because it won't support your workload, which is a reality, or because you don't want to pay for it, or you think that you can be more efficient and cost effective than Fargate is by managing your own cluster of compute, then you could look at alternative host operating systems. So you could run like Bottle Rocket, for example, which is a super secure, very locked down. It's like SE Linux on steroids for containerd based workloads, or Firecracker VM kind of technologies.
I thought it was Contain Nerd.
Right. And then in the EKS world, I think there's even other features, right, Toby? I'm not sure.
With respect to Fargate?
No, with respect to sort of knobs and dials and security measures that you can apply to help with the escapability problem when you're running pods for more than one tenant on a single node.
Yeah, you could restrict a service account from you can't run as root or whatever, right? So that if you were able to pop outside of the container, that process that's actually hosting that container is fairly limited in scope. That gets into some really, really like maybe we should have a container specialist in here one day to talk about that specifically, because that's a deep hole that we can go down.
Now, just to for a little bit of contrast, if you look at deployment time in a serverless environment, and you look at what that looks like, here you'll deploy the Lambda function with the constraint already on it, like we talked about earlier, the execution role. And in this model, our example, in fact, this is in the reference architecture this way. When you hit the API gateway and then it uses the authorizer to resolve what your access is, it can just use the execution role that's already attached to that function and not have to do a whole lot to worry about isolation, versus the sort of alternate version, which is the runtime version of this. If now when you come through the API gateway and the authorizer goes out, it actually does the assume role, it gets the credentials, it figures out your creds, and it actually injects the creds downstream to the microservices. And by the way, this was a lot of controversy in our team about whether that should happen at the authorizer level or whether or not the individual microservices are doing it. But here's an entirely different mechanism and a different realization of that sort of deployment time versus runtime strategy played out with Lambdas. So I think the broader takeaway here is I'm hoping I wanted to show you EKS and serverless at least, and then also we didn't even dig into individual services to get you to realize you have to really look at the footprint of your architecture and figure out which combinations of these things, depending on the deployment model and everything else in my application, are going to be the right mix to build the isolation story. And just know that some of this might mean you got to go build some of it on your own, right? So I'm curious if you guys want to step back from these individual technologies. If you what advice would you give to somebody going away and who's got to go build their own isolation policy? Any takers there?
I mean, I think, I'll just echo what Bill said before, is that you got to think about it at all the levels of your system, right? It's not database and how your tenants access the data within that database is half of the issue. You got to think about, where the websites are. Is there a vector through which, that could be an issue? The compute stack, all the levels, just think through all that, make that part of your design, make that an eyes wide open kind of thing versus just something you're shoring up when the PCI DSS auditor comes in or something.
Right. And back to the, plumbing discussion earlier, to understand if there are portions of your overall infrastructure footprint that are really there for movement of data, not processing of data. Mm-hmm. And do those have to be isolated, or can that be shared?
Right. And keep an eye on the marketplace too for fine-grained access control. I think we've mentioned OPA along the way, and I think using Rego and OPA, I've seen that on a number of customers for sort of creating their own sort of framework in addition to not accepting or exclusive to IAM, but in addition to that. And I'm looking at some others out there too. I think Auth0 is working on their own fine-grained access control, and I think there's a few others in process. Cool. Sort of look at that marketplace and see if there's anything else you can leverage before you go build your own too.
Awesome. Well, I know we're at time. I hope this sort of coarse-grained sort of view of this was super helpful in terms of helping you navigate this. Definitely enjoyed the session myself at least, and enjoyed having you all join us. So. Look forward to having you being part of our next session. So have a good day. Thanks, everybody.
Thanks, everybody.
Thanks, everyone.